So today we will learn about redox reaction. So let's get started. In redox reaction we have to study oxidation state or oxidation number, and then we will learn about the balancing of redox reaction, which is the most important part of our redox. Then we will talk about redox calculation of n factor, and at last we will learn about we will learn about redox titration. So let me start with oxidation number or oxidation state. So get started. So as you know that there are two types of compound we have learned in 9th and class: ionic or covalent compound. So in ionic compound there is simple. For example, in the ionic compound is that which are formed by sharing donating electron or getting electron. So, for example, if we talk about NaCl, so as you know that Na has plus one charge and Cl has minus one charge. So this is the oxidation state of ionic compound. For example, if we talk about MgCl2, so it is plus 2 and it is minus 2. As you know that Na has tendency to gain one electron and Cl has tendency to gain, as you know that to complete its octet it has to gain one electron. So whatever electron it gain, that will be its charge, and that charge will convert into its oxidation number. For example, Mg belongs to second group of periodic table, so it has two elements in its outer shell only. As you know that chlorine in its is present in 17th group and it has 7 electron in outer shell. So it will gain one electron in order to complete its octet. So both will complete with octets and both will get plus 2. No, it is minus 1, because there are two because there are two chlorine, so each will get minus 1 to balance. And as you know that in ionic compound the charge overall charge is 0. So now we will talk about the covalent compound. Now we will talk about covalent compound. As you know that in covalent compound, for example, if you know about, wait, now let's talk about covalent compound. As you know that covalent compound has no charge, so it will carry an imaginary charge. And in NaCl, for example, in ionic compound in NaCl, it has real charge. And in covalent compound, let's talk about an example: CO2. So as you know that CO2 has no charge, carbon has no charge, oxygen has no charge. So it will carry in imaginary charge, that is virtual charge. So if you talk about in, as you know about the electronegativity of an atom. So let's talk about electronegativity of atom. So example, there are two atoms A and B. If A is more electronegative and B, if suppose A is more electronegative and B is less electronegative, then it will carry plus 1 charge and it will carry minus 1 charge. But in redox reaction we will simply carry it as minus 1, and simply it will say about plus 1, because in taking plus 1 charge we have more easily to understand. So let's talk about CO2. What is its oxidation number? Carbon is more oxygen is more electronegative electronegative. So if you talk about its structure, so it is oxygen, it is carbon. Oxygen is more electronegativity, so it has -2 charge, and it has also -2 charge. For this -2 there will be +2 charge. For this oxygen there will be +2 charge. So in overall it has +4 charge. So now let's talk about the rules of electronegativity. Rules for oxidation number in covalent compound. So let's talk about this. अब चलिए रूल्स के बारे जान लेते हैं। सबसे पहला, कोई भी एटम, कोई भी मॉलिक्यूल अगर वो अपना एलिमेंट्री स्टेट यानी नेचुरल स्टेट में अगर पाया जाता है तो उसका जो चार्ज होता है वो जीरो होता है, यानी कि उसका ऑक्सीडेशन, ओवरऑल ऑक्सीडेशन नंबर जीरो होगा। फॉर एग्जांपल, इफ यू टॉक अबाउट O2, it is present in its elementary state, so its charge is zero. So if you talk about H2, so its charge is zero, it is present in its elementary state. If we talk about N2, if we talk about O3, ozone, it is also present in its elementary state, so its charge is zero. If we talk about iron, so its overall charge is zero. So now it is the rule number one. Now we will discuss about the second rule. Second rule is so easy. As you know that in periodic table, now as you know that in periodic table, this is first group S block. Now in S block there are two. This is first group. We know that by the name 1A. And this is 2B. Now in 1B there is hydrogen, lithium, sodium. Now I will make it big. So in periodic table, as you know that this is first group, this is known as alkaline metal, and this is known as alkaline earth metal. Now we have a trick to learn the atoms of first group. लीना के रब से फरियाद, and this is beta मांगे कन्या सुंदर बाप राजीव. We have excluded hydrogen because as there is an exception in hydrogen, so we will talk about in third point about hydrogen. So this is known as alkali metal, and this is known as alkaline earth metal. This is first group metal, this is second group metal. So it has +1 electron in outer shell, in outermost orbit, so it will lose one electron in order to gain its octet complete, and it will go low. It has +2 electron in its outer shell orbit, so it will lose 2 electrons in order to attain stability. So it has +1 oxidation number, and this has +2 oxidation number. So now let's talk about another point, that is about the hydrogen. So here we start. So as you know that hydrogen is present in first group, and it has only one electron. It's first in its outer shell, so it will lose one electron in or gain one electron to attain stability. So it has sometimes +1 +2. Generally it has +1 oxidation number, hydrogen. For example, if you talk about an example, that is about, let's say, HCl, hydrochloric acid. Chlorine has -1 charge because it is more electronegative, and hydrogen has +1 charge. The overall compound has zero charge. +1 -1, it will become neutral. If you talk about when it is attached to less electroनेगेटिव एटम, तब उसका ऑक्सीडेशन नंबर हो जाएगा +1। +1 अभी है, और उसका ऑक्सीडेशन नंबर -1 में बदल जाएगा। यानी कि कोई भी मेटल का बात करें, जैसे कि NaH, तो Na का होता है +1, तो हाइड्रोजन का हो जाएगा -1. So this is the oxidation number of hydrogen. Now let's talk about the oxygen. As you know that oxygen is present in 16 group, and it has 6 electrons in its outermost orbit, so it will gain 2 electrons. So generally oxygen has -2 oxidation number, but there are some exceptions. It is -2 only when it is attached to more with less electronegative atom. For example, if we talk about H2O, H2O, MgO, COC, Cl2O. Let's talk about MgO. As you know that Mg is second group element, so it has +2 oxidation number, then oxygen has -2. Then oxygen has -2 oxidation number. But there are some exceptions. There are 3 exceptions in case of oxygen. Now let's talk about those. Now first exception is here. That is peroxide. As you know about H2O2, it is also a peroxide. So if you talk about H2O2, so let's draw the structure. H2O2. So its structure is like something this: H, single bond O, single bond O, and another H. Hydrogen, as you know that it is +1, so oxygen will be -1. Hydrogen again +1. For this oxygen atom there will be 0 because they are similar atom, both are same electronegative, and this is -1. Now this is the case of the superoxide. It is -1 and -1 in each of the following. Now if we talk about the superoxide, so let's talk about superoxide. So if you take example superoxide, if you take examples such as KO2, NaO2, so let's talk about KO2. It is potassium, it is present in first group, so it has +1 oxidation number, and it's for oxygen. It is low, let's consider it X. Its overall charge is 0, so +1 +2x is equal to 0. So here it will come. Now if with 2x is equal to -1, x will be minus half. Now if we talk about another exception, that is hydroxyfluoride, that is O2 and O2F2 and OF2. So let's talk about OF2. OF. As you know that fluorine is always is the most electronegative atom. So if so it has, then it has minus one charge, it has minus one charge, then it will carry, for example, if we take it at the oxidation state of oxygen as X, then it is minus 2 is equal to 0. So in this we have, now let's talk about its structure. So OF2 is something like this: O in central atom and single bond fluorine, and again single bond fluorine. So fluorine has minus 1, for this it has plus 1, it has minus 1, for this it has plus 1, so it has plus 2. From from here it also come, from here it also come plus 2. For example, if we talk about x minus 2 is equal to 0, so x will be plus 2. Now we again talk about halogen gas in next page. So let's get started. The oxidation state of halogen is generally minus 1. Halogen is generally minus 1 when attached to less electronegative atom. For example, if we talk about example of halogen are fluorine, it is 17 group element. Fluorine, chlorine, bromine, iodine, etc. But when, for example, if you talk about HF, fluorine has minus, hydrogen has plus 1, and fluorine has minus 1. So it is single bonded electron, and fluorine is more electronegative. Now let's talk about another case, it exception. So let's talk about its exception. When it is attached to more electronegative atom, then the oxidation state of hydrogen is positive. For example, if you talk about OCl2, it is ClOCl. Cl Cl has minus 1 charge. Again, Cl is minus 1. In chlorine and oxygen, chlorine is more, oxygen is more electronegative atom. So it will not get plus 1, it will get plus 1, and it will get minus 2. So this is the exception case. For example, if we talk about IF7, iodine I IF7, iodine in central and 7 fluorine are attached. 1, 2, 3, 4, 5, 6, and finally 7. Fluorine is more electronegative, so it will carry -1, -1, -1, -1, -1, -1, -1, and -1. For all this -1, it will get +7. So here rules will get completed. Now let's discuss some problems related to solving oxidation numbers. So let's get started. So let's take an example like sulfate ion SO4 2 minus. In SO4 2 minus we know about O4 and we have to calculate about sulfur. So whenever we have to calculate any oxidation state, we have to know what in question it is underlined, and if it is not underlined then it is the common sense that what we know we will write and what we not know we will calculate. So let's get started. So how to calculate oxidation state? So let sulfur oxidation state of sulfur be as oxygen. There are four oxygen and oxidation state of each oxygen is -2 and overall charge we will write here. So if we solve, so so x x plus y is equal to -2. So while we have to solve this equation only and we will get a result. So x minus 8 is equal to -2. So x is from here, x is +6. So let's talk about another example, that is phosphate ion. So here we have to calculate oxidation state of phosphate. So let x plus 4 into oxidation state of oxygen -2 is equal to -3. So x minus 8 is equal to -3. So x is equal to -3 plus 8, that is +5. Now let's talk about some another example. So here it get started. So let's do some example. So first example is Cr2O7 2 minus. So we have to calculate chromium. So one number of elements into which have to calculate oxidation state. Let it assume 8 plus 7 into -2 is equal to -2. So it will come x is equal to +7. So let's do some more example. For example, we have to give H2O3 2 minus. So we have to calculate here H2. So let it 2x minus 6 is equal to -2. For solving here it will come 2. Now let's talk about ammonia, that is NH4 plus. So NH4 plus. Let's we have to calculate nitrogen. X plus 4 is equal to 1. From here x will come -3. So you have to calculate, we have to do practice from any source. If you don't get any source, we have to just Google it and practice more as many possible, as many questions. So if IIT asks, then you have to be careful. You have to practice so much that you will not get afraid from, because it is used in oxidation, balancing of redox reaction. Now there are some exceptions. For example, if you talk about Fe3O4, so we have to calculate Fe. So it is 3x. Here x will come 8 by 3. So as you know that this is not charge. So if whenever it is the average oxidation number, so whenever such problem come, then we have to draw its structure and calculate it. So let's go started with some structure. So if you talk about some structure, so today we are going to discuss some structure and you have to practice some. We are going to read structure in chemical bonding chapter. But here, for example, C chromium CrO5. So chromium in center and there are five oxygen. So for each oxygen, then it is will be minus one. For each bond, there will be minus one. For each single bond, and there is double bond, so this will be plus minus 2. So overall 1 1 2 3 4 2 6, so it will become plus 6. So it is like some butterflies and its structure is blue. So we have named it as blue butterfly. Its structure, if someone asked, then we will say it is blue butterfly. Now let's talk about if when we are going to और जब हम इसका ऑक्सीडेशन नंबर निकालेंगे तब देखते हैं कितना नॉर्मल मेथड से क्रोमियम का निकालना है, तो x मान लेना है x minus 10 is equal to minus 2. So it will come plus 8. So it is average oxidation state. Now let's talk about another structure. Now let's talk about another example, that is coarse acid, that is H2SO5. So it is like H2SO4. So in H2SO4, if we add one oxygen, then it will become this. So now let's draw it structure. Now let's draw it structure. So as you know that structure of H2SO4, by the help of structure of H2SO4 we are going to draw the structure of H2SO4. So in center there is sulfur atom, double bond oxygen, this is the structure of H2SO4. So we have to add to one oxygen. So let's draw it. So here we add one oxygen and one hydrogen. Now let's talk about its oxidation state. By the normal method, if you calculate its oxidation state, now we will calculate after calculating this. For there is -2, for this there will be +2, there will be -2, for this in sulfur we will get +2, for this there will be -1, for this there will be +1, for this there will be -1, for this there will be +1. So it will come 2 to 4 1 5 plus 6. So it will come plus 6. If we go with normal method, now let's calculate with the help of normal method. So let's think which answer will come. And it is H2SO5. So let's calculate with the help of normal method. We have to calculate sulfur. So as we know, outside of 2x, no 2, only 2, plus 2 plus 2 plus x minus 10 is equal to 0. It is -8 plus x is equal to 0. So it is x is equal to 8. So here our topic ended. So let's meet in another class. Thank you. Please subscribe it. Thank you for practice more.